Hey everyone, and welcome. Ever looked at a complex piece of software and just wondered how on earth do they build that? Well, it almost always starts with two fundamental ideas, classes and objects. Today, we're going to take these concepts from just words on a page to real working code. Let's dive in. So here's our game plan. We're going to start with a super simple goal, but you'll see that we hit a wall pretty quick. That's when we'll discover how classes and objects are the heroes of the story. We'll go from designing the blueprint to actually bringing it to life, and then we'll make our creation genuinely useful. You ready to build something? Let's go. All right, so our mission for this explainer, it's about as simple as it gets. We just want to add two numbers together. That's it. But this very simple task is the perfect way to show you why organizing our code is so incredibly important. Now, if you didn't have any fancy structures, this is probably how you do it. You can see the steps here. Create a number, create another number, add them, print the result. Super straightforward. And for a tiny program like this, it works just fine. But imagine this was just one small part of a huge application. This style of just listing instructions gets messy fast. We need a better way to keep our logic organized. And that brings us to the first big idea, a class. Now, a class isn't the final thing, it's the design. Think of it like this. An architect has a detailed blueprint for a house long before a single brick is laid. In Java, a class is our blueprint for logic before we can actually put it to use. So what is a class, really? It's a blueprint, a template. It's the master plan that defines what something will know, that's its data or variables, and what it can do, those are its behaviors or methods. It's the plan, not the thing itself. Okay, here's our very first blueprint. It's a class we've named calculator. And inside, we've defined a behavior. In Java, we call this a method. Our method is called add. Now, for now, it doesn't really do any math. It just prints a little message and returns 0. This is our initial design for any calculator we might want to make later. So, we have our blueprint. Let's try to use it. Back in our main program, we just try to call our add method. And bam, error. Java screams at us, cannot find symbol. But wait a second, the method is right there. We just wrote it. Why can't Java see it? This right here is a super important moment in understanding how Java thinks. The reason we got that error is because we're missing the key ingredient. Having the blueprint for a house is great, but you can't live in a blueprint, right? You need an actual physical house. In Java, we need an object. So why did our code really fail? Well, the problem is that Java was looking for that add method right inside our main program. But we didn't define it there. We defined it inside the calculator blueprint. To use the blueprint, we first have to actually build something from it. This slide just nails the difference. A class is the abstract idea, the blueprint, the design, the recipe. An object is the concrete, real-world result, the actual house, the phone in your hand, the cake you can actually eat. We've written our recipe, now it's time to bake the cake. And that's exactly what we're going to do right now. We're going to take our calculator blueprint and use it to construct a real working calculator object that can finally solve our problem and get rid of that error. Okay, the code for creating an object might look a little weird at first, but it's really logical. Let's break it down. First, calculator calc. Think of this as creating a remote control for our object. It doesn't control anything yet, it's just a remote. Second, new calculator ... That new keyword is magic. It's the command that tells Java, hey, go actually build that object in memory for me. Finally, the equal sign just connects our remote control to the brand new object we just built. And here is the solution in action. We create our calc object. Then, instead of just calling add, we use our remote control to access it, calc.add. That little dot is like pressing a button on the remote. We're telling Java, hey, use the add method that belongs to the calculator object I just built. And just like that, the error is gone. It works. Okay, our code runs without errors, which is awesome. But let's be honest, our add method is still pretty useless. It always returns 0. Now we need to upgrade it so it can actually do the calculation we wanted to do from the very beginning. Let's make this thing smarter. So we've hit our next little puzzle. Our numbers, 4 and 5, are living over here in our main program. But our add method is inside the calculator object. They're in two separate worlds. So how do we get the numbers from our program into the add method so it can do its job? The solution is to use something called parameters. It's like sending data through a mail slot. First, when we call the method, we put the data we want to send right inside the parentheses. Second, we have to update our method's definition so it's ready to receive that data. So you can see num1 gets copied into a new variable called n1, and num2 gets copied into n2. And now our method has the numbers it needs to do the math. And here it is, the whole shebang. Our main method preps the numbers, creates the calc object, and then calls the add method, passing our numbers along. Inside the calculator, the add method receives those values, does the math, and uses return to send the answer back out. That answer gets stored in our result variable, and we print 9. We've done it. It works perfectly.
Phew, we've covered a lot of ground here, right? We went from a simple little problem to a really elegant, object-oriented solution. Let's do a quick recap of the essential syntax you just learned so you can add it to your programming toolkit.
These right here are the 4 key patterns you've just mastered. You now know how to define a class, how to create an object from it, how to define a method inside that class, and how to call that method. If you master these 4, you are well on your way to being a solid Java programmer. This table is a great thing to bookmark. So we went from a simple idea to a structured, reusable piece of code. You now have the power to design blueprints with classes and build real tools with objects. The only question left is, what are you going to create? Thanks for watching and happy coding!